The last part of this week is a basic method that we can use to actually solve a system of equations called Cramer's rule. So Cramer's rule is just a process of calculating a whole bunch of determinants and dividing them in a systematic way in order to solve a system. So as long as our determinant of A isn't equal to 0, which makes sense, because if the determinant of A is equal to 0, then we don't have an inverse, we can't find a solution, then the solution is given by this. So my first unknown is going to be the determinant of A1 over the determinant of A. My second unknown is going to be the determinant of A2 over the determinant of A. And then my third unknown is going to be the determinant of A3 over the determinant of A, etc. AK, so A sub a number, is a special matrix where the kth column is replaced by the B vector of the system. So let's go ahead and look at what that is. So let's say I have a system of equations. A looks like this. And B looks like this. Then A, determinant of A, I can go ahead and find that determinant here using the methods I talked about in the previous videos. Determinant of A1 is going to be taking A and replacing this column here with B. So this is A1, which means I'm going to go ahead and slot B into the first column. And then the remaining two columns of A fill in. And I would find the determinant of that matrix. Then I can go ahead and find the determinant of A2. Notice this is a 2, which means the second column of A is replaced with B. So I'm going to go ahead and put in my first column of A. Oops. Then I put in the second column is going to be my B values. And then my last column of A. And then determinant of A3. This here is 3, so I'm going to replace the third column with my B vector. So first two columns of A stay the same. And then my last one is replaced with B. And there you go. You would find 4 determinants for the system. A, A1, A2, A3. Then your unknowns, X would be the determinant of A1 over determinant of A. Y would be the determinant of A2 over A. And Z would be the determinant of A3 over the determinant of A. And there we go. That's it. So with 4 determinants here, I can solve my system of equations. With 5 unknowns, you can use 6 determinants, etc. So our process is to find all of our determinants. So find the determinant of A. If it's equal to 0, you're done and you can't do anymore. If it's not equal to 0, then you can go ahead and find the determinant of A1, determinant of A2, determinant of A3, however many columns in A you have. Just replace them systematically one at a time with your B values. Once you have all your determinants, go ahead and solve for your unknowns. Take each AK, divide it by the determinant of A, and that will give you your answer. So it's a nice method that we can use. It's not always necessarily practical. Determinants are computationally heavy in terms of calculating them, especially as your matrices get larger. But it is a method that you can use in order to solve a system. Sometimes determinants are easy to find, sometimes they're not easy to find. So it really just depends on what your system looks like.